Hello out there dear friends, and welcome to this video today in our YouTube channel. In this video we shall be evaluating the improper integral going from 0 to infinity of the limit as n goes to infinity of 1 plus 1 our cosine of 1 over n, all that goes to the power the square root of 1 minus sine squared 1 over n to the power negative 2 dx. So friends, please watch this video from start to finish, because at the end of this video you shall understand the concept so well, guys. And if a similar question like this comes in your calculus exam or your board exam or your GC advanced level or ordinary level and so on, you shall be able to tackle it without any ease. Great. So friends, let's dive straight into the video. But friends, please don't forget to subscribe to the channel, share the video with your friends so that they can have access to good content like this, and don't forget to visit our blog every day, guys, because we post contents every day. We post numerous contents every day, so you can afford to miss. Let's dive straight into our video. So friends, as we see this our problem, we see that the only guy here that looks pretty crazy, right, is this square root, right? So let's try to see if we can reduce that down. But we know that sine squared of 1 over n plus cos squared 1 over n is the same like what, guys? 1. So to produce a 1 minus sine squared 1 over n, we simply carry this sine squared 1 over n to the right hand side. We are going to have cos squared 1 over n to be the same like 1 minus sine squared 1 over n. But we need a square root, so we'll take the square root on both sides. We are going to have cos of 1 over n to be the same like the square root of 1 minus sine squared 1 over n, right? Which is the same thing that we have here. So friends, we can now go for now to replace this our original integral as the integral going from 0 to infinity of the limit as n goes to infinity of 1 plus 1 over cosine of 1 over n, all that goes to the power all of this, which is simply 1 over cosine of 1 over n. So we have it here, all that goes to the power negative 2x dx. Good. So friends, at this point in time now, we are going to take one step at a time. We will start by evaluating the limit of this entire function before we now evaluate the improper integral going from 0 to infinity. Good. So friends, to take the limit, let's do some kind of substitution, guys, and see what we can get. Let's investigate it here and see, friends. Let's investigate and see. Good. Everything is set up now, guys. We are going to try to substitute. We are going to look for a stable substitution to substitute with 1 over n. So we are going to let our y to be something like 1 over n, guys. So that if we now take the limit now as 1 over n, we now take a limit as n goes to infinity of 1 over n, guys. When n goes to infinity, this whole result simply gives us what? 0, right? We simply have our answer to be 0. That therefore means that our y, which is 1 over n now, will be going to 0, right? Means y now will be going to 0. So now this our limit now turns out to be the limit, turns out to be the integral from 0 to infinity of the limit. Now this n now we are going to have as y goes to 0, okay, as y goes to 0, because when n goes to infinity, as we saw here now, what 1 over n was going towards, so it was 0, and 1 over n has the value of what? Y. So y will be going now from 0 of 1 plus 1 over cosine of 1 over n, as we know here is what, guys? Y. All that raised to the power cosine of y, all that raised to the power negative 2x dx. Good. So friends, at this point in time now, if we put our y to be 0, we'll take y to be 0 and put into everywhere we are still going to have the integral from 0 to infinity of, we have 1 plus cosine of 0, because y is going to 0, we substitute y to be 0, of 1 over cosine of 0, all that raised to the power cos 0 to the power negative 2x dx. As you all know, guys, cos 0 simply gives us 1, right? Nicely. Good. It looks so nice. We are now going to have the integral going from 0 to infinity of cosine of 0, guys, is 1, right? 1 plus 1, the 1 we get, that we are going to have 1 over 1, which gives us 1. The 1 plus this 1 gives us 2. That's why we have this 2 here raised to the power. Cos 0 is 1. Then we have negative 2x dx. Good. So friends, this is what we have at this point now. Then what we are going to do now is that we are going to look at this 2 and we write that as e raised to the power the natural log of 2, because the e and the natural log can cancel. So we are going to have the integral going from 0 to infinity of e raised to the power the natural log of, we have 2 to the power negative 2x. you can see that the e and the natural log, they can cancel and we still have back our 2, which is what we have here. But you see the beauty of doing so. So friends, at this point now, we are going to take negative 2x and we distribute inside this natural logarithm. Then we are going to take x now and put at the back. When this negative 2x comes, it therefore gives us 2 raised to the power negative 2, right? And that's going to give us 1 over 4. Cool, 1 over 4, guys. So we are simply just going to have now the integral from 0 to infinity of x of e raised to the power x natural log of 1 over 4 dx. Good. So friends, you see that at this point in time now, we can therefore evaluate our definite integral going from 0 to infinity, because the integral of e raised to the power anything, it simply gives us 1 over the natural log of the derivative of the power, then we multiply by the function itself. So we are simply just going to have 1 over the natural log of 1 over 4 e raised to the power x natural log of 1 over 4. Good. Then friends, okay, we now have this. Now the limits of integrations are from infinity, we have from 0 to infinity. Good. So the limits of integrations. So friends, we know that the natural log of 1 over 4 now is the same like negative of the natural log of 4, right? The same like negative ln 4, because we can write 1 over 4 as 4 raised to the power negative 1, right? 4 raised to the power negative 1. Then now we can now shift the negative to the outside and have what I said initially, that is negative ln 4. Good. So we are simply just going to have now negative of 1 over ln 4 e raised to the power. We do the same thing here. Negative comes and we have negative x natural log of 4. Limits are from 0 to infinity. Good. So now if we substitute everything, if we substitute infinity and 0, because guys, remember that putting infinity into this guy means we are taking another limit as n goes as x goes to infinity, and when x goes to 0. Good. So now if we put infinity, now we are going to have negative 1 over ln 4 is outside as a constant. Then we have e raised to the power negative x is, we have ln 4, we have infinity, then we have ln 4 minus e raised to the power x is 0. The 0 cancels the negative, we have this, right? But we know that when n goes to infinity, guys, this part goes to 0, right? This part goes to 0. Then likewise this part goes to 1, right? Because e raised to the power anything is simply 1. Then the negative gives us negative 1. The negative 1 times the negative simply gives us a positive value. So at the end, guys, we have ours to be 1 over ln 4. Good. So friends, that's the solution to our problem, and please put in the comment section down below if you have any question or you didn't understand the concept, and I'm going to explain very well for your convenience, guys. Don't forget to subscribe to the channel and like the video, friends, if you found it useful to you. Thank you very much, guys, and see you in the next video. Stay safe, guys, and have a great day.